Picture this moment. You're standing on a moonlit shore, watching as the ocean breathes. The water advances toward your feet with ancient patience, then retreats, leaving behind a mirror of stars scattered across wet sand. This rhythm, this eternal inhale and exhale of the sea, has been Earth's heartbeat for over 4 billion years. But tonight, as you listen to the gentle susurrus of waves against stone, consider this unsettling possibility. What if these tides carry more than salt and seaweed? What if, hidden within their endless cycles, lies a secret diary of our planet's forgotten past? The ocean before you holds mysteries that would make the most elaborate conspiracy theories seem mundane. Every wave that touches the shore carries whispers from eons long buried, messages encoded in the very rhythm that has lulled countless generations to sleep. Tonight, we'll dive beneath the surface of the familiar to discover how the simple rise and fall of water might unlock Earth's most closely guarded secrets as the tide pulls back, revealing tide pools that mirror the cosmos above. You might wonder, could these predictable waters actually be unpredictable storytellers, preserving evidence of vanished worlds, lost civilizations, and cosmic events that shaped our planet in ways we're only beginning to understand? The mystery begins here, in the space between high and low tide, where the ocean's memory meets the shore. Long before satellites tracked weather patterns or atomic clocks measured time, there were watchers by the sea. In the pre-dawn darkness of ancient Mesopotamia, Sumerian priests climbed ziggurats to observe the night sky. But their most trusted timekeeper wasn't written in stars, it was written in the rhythm of distant tides along the Persian Gulf. These early civilizations possessed an almost supernatural understanding of tidal patterns. Sumerian tablets, carved over 5,000 years ago, described tidal cycles with mathematical precision that wouldn't be matched by Western science until the Renaissance. They called the tide the breath of Tiamat, their primordial goddess of chaos and salt water, believing that each rise and fall carried divine messages about the future. Across the Mediterranean, Egyptian priests noticed something equally remarkable. The Nile's annual flood, which brought life to their desert kingdom, seemed mysteriously connected to both lunar cycles and distant ocean tides. They developed a complex calendar system that interwove these celestial and maritime rhythms, creating what they called the mathematics of eternity. Modern oceanographers have confirmed that these ancient Egyptians somehow understood tidal harmonics that we're still studying today, but perhaps no civilization read the tides with greater mastery than the Polynesians. Using nothing but outrigger canoes and inherited wisdom, they navigated thousands of miles of open ocean by interpreting the subtle interference patterns created when ocean swells interacted with underwater mountains and distant islands. They could sense the presence of land over the horizon by reading how tides bent and curved around invisible obstacles. These Pacific navigators spoke of wave pillars, standing waves created by tidal interactions with seamounts that served as highways across the seemingly empty ocean. European explorers, armed with compasses and maps, often became hopelessly lost in the same waters where Polynesian wayfinders could pinpoint their location to within a few miles using only the feel of waves against their canoe hulls. The ancient Greeks took this tidal wisdom in a different direction. Aristotle wrote extensively about what he called the cosmic sympathy between celestial bodies and earthly waters. He theorized that tides were not merely caused by the moon, but were part of a vast, interconnected web of cosmic influences that connected the smallest tide pool to the largest celestial events. What these ancient peoples seemed to understand intuitively was that tides were never just about water. They were about time itself, about the deep connections between Earth and cosmos, about patterns that stretched back to the very formation of our solar system. Their careful observations, passed down through generations of oral tradition, contained insights that modern science is only now beginning to appreciate. As we stand on the shores they once watched, we inherit their question. If tides could serve as cosmic calendars for ancient civilizations, what other secrets might they be keeping? To understand how tides might preserve Earth's hidden history, we must first witness the cosmic choreography that creates them. Imagine, if you will, the moon as a celestial dancer, locked in an eternal waltz with Earth across the ballroom of space. This dance began over 4 billion years ago, when a Mars-sized object collided with the young Earth in a cataclysmic event that ejected enough material to form our Moon. From that violent birth emerged one of the solar system's most elegant partnerships, a gravitational romance that has been shaping our planet's destiny ever since. The Moon's pull on Earth's oceans creates what scientists call a tidal bulge, but this simple term barely captures the profound reality of what's happening. As our planet spins beneath its lunar partner, the Moon's gravity reaches down through space to literally lift billions of tons of water, creating a permanent wave that travels around the globe. This isn't just physics. It's poetry written in water and gravitational force. But here's where the story becomes truly remarkable. The Moon doesn't just create tides. Tides create the Moon's future. Every time water rises and falls against the shore, friction steals a tiny amount of Earth's rotational energy and transfers it to the Moon's orbit. This means our celestial partner is gradually spiraling away from us, moving about 1.5 inches farther from Earth each year. This cosmic dance has been slowing down Earth's rotation since the very beginning. 4 billion years ago, when the Moon was much closer, days lasted only about 6 hours, and tides towered hundreds of feet high, reshaping coastlines with every cycle. The Moon appeared enormous in the sky, nearly 10 times larger than it does today, casting shadows so sharp they could cut glass that eons passed. This gravitational friction gradually lengthened our days and calmed our tides. The process continues today, adding about 2 milliseconds to each day every century. It sounds insignificant, but over geological time, these tiny changes accumulate into dramatic transformations. The beauty of this system lies in its perfect balance. The Moon stabilizes Earth's axial tilt, preventing the wild climate swings that would make complex life nearly impossible. Without our lunar partner's gravitational influence, Earth would wobble chaotically, experiencing ice ages that could last millions of years followed by periods of scorching heat. This celestial partnership has literally shaped the conditions that allowed life to emerge and flourish on our planet. The regular rhythm of tides may have provided the perfect environment for early organic molecules to concentrate and combine in tidal pools, creating the first spark of life. Every night, as you watch the Moon rise over the ocean, you're witnessing a cosmic clock that has been keeping time since before life itself existed. A timekeeper whose records might hold the key to understanding not just where we came from, but where we're going. Hidden within the most unlikely places, in limestone cliffs, ancient coral reefs, and layers of sedimentary rock, lie some of Earth's most extraordinary storytellers. These are the tidal rhythmites and growth rings that serve as nature's own archive, preserving the planet's rotational history in microscopic detail. Deep in the Grand Canyon, geologists have discovered something that would sound like science fiction if it weren't carved in stone. Layers of rock formed 900 million years ago contain ripple marks, fossilized patterns created by ancient tides that reveal Earth was spinning much faster in the deep past. By measuring the spacing and orientation of these prehistoric wave patterns, scientists have calculated that a day lasted only about 18 hours when these rocks were formed. But the most remarkable tidal archives come from ancient coral reefs. Modern corals add a new growth ring each day, like trees recording annual cycles. When paleontologists examine fossil corals from 400 million years ago, they find something astounding. These ancient creatures recorded days that lasted only 22 hours. In years that contain nearly 400 days, these coral chronometers don't just tell time. They reveal the intimate relationship between Earth's spin, the Moon's orbit, and the evolution of life itself. Each microscopic growth band represents a daily tide cycle, preserved in calcium carbonate like a message in a bottle from the deep past. Perhaps even more intriguing are the stromatolites, layered structures created by ancient bacterial mats that thrived in tidal zones billions of years ago. These living rocks, some of the oldest evidence of life on Earth, contain layers that correspond to daily, monthly, and annual cycles from when our planet was young and alien. In Western Australia, stromatolites dating back 3.5 billion years show tidal patterns from an era when the moon was so close that it would have appeared as a looming disk covering nearly a quarter of the sky. The tides these ancient microbes experienced would have risen and fallen every few hours, creating a rhythmic environment that may have been crucial for early life's development. Scientists have discovered that these prehistoric tidal cycles created concentration gradients, areas where organic molecules would accumulate during low tide and mix during high tide. This natural chemistry lab may have provided exactly the right conditions for the first self-replicating molecules to emerge. Even more mysterious are the tidal rhythmites found in places like the Bay of Fundy, where layers of sediment preserve tidal cycles from hundreds of millions of years ago with such precision that scientists can determine not just the length of ancient days, but also the exact orbital dynamics of the Earth-Moon system throughout deep time. These geological timekeepers reveal that Earth's rotation hasn't just slowed gradually, it's experienced periods of acceleration and deceleration tied to major geological events. Ice ages, massive volcanic eruptions, and even asteroid impacts left their signatures in the tidal record. As we examine these ancient archives, a startling possibility emerges. If tides have been meticulously recording Earth's history for billions of years, what other secrets might be hidden in patterns we haven't learned to read yet? In the deepest ocean trenches, where sunlight has never penetrated and pressure would crush a human body in microseconds, lie the scattered remains of vanished worlds. Here, in the perpetual darkness of the abyssal plains, tidal forces still pulse through water that once washed over continents now lost to time. The story of these sunken lands begins with a simple observation that has puzzled geologists for centuries. Similar fossils, rock formations, and mineral deposits appear on opposite sides of vast oceans, as if continents once fit together like pieces of a jigsaw puzzle. But it wasn't until scientists began studying ancient tidal patterns that they discovered how these geological mysteries might be solved. Consider the enigma of the Kerguelen Plateau, a massive underwater landmass in the southern Indian Ocean. This submerged continent, nearly the size of India, now lies beneath miles of water. But geological evidence suggests it was once a lush, temperate landscape. Ancient tidal rhythmites found in drill cores from this underwater realm tell a fascinating story. They preserve evidence of complex shoreline interactions from when this land stood above sea level, complete with rivers, lakes, and coastal ecosystems. The tidal signatures locked within these sediments reveal something extraordinary. The patterns don't match what we would expect from the current ocean configuration. Instead, they suggest a world where sea levels were dramatically different, where ocean currents flowed along paths that no longer exist, and where the very shape of ocean basins was fundamentally altered. Even more intriguing is Zealandia, the mostly submerged continent that includes New Zealand and New Caledonia. Recent analysis of tidal deposits from this underwater realm has revealed evidence of massive tidal bores, walls of water that rushed inland along river systems when this continent was partially above sea level. These ancient megatides, preserved in sedimentary layers, paint a picture of a landscape that would seem alien today, but perhaps the most mysterious tidal evidence comes from the Mediterranean Sea. Buried beneath its floor lie salt deposits over a mile thick, evidence that this entire sea once dried up completely during an event called the Messinian salinity crisis. Tidal rhythmites from this period, preserved in marginal basins, reveal that when the Mediterranean was a vast salt desert, tidal forces from the Atlantic still influenced hypersaline lakes that dotted the basin floor. These underwater archives don't just record the rise and fall of sea levels, they preserve evidence of how Earth's entire climate system has shifted over geological time. Changes in ocean basin geometry affected global tidal patterns, which in turn influenced ocean circulation, which altered climate patterns worldwide. Some of the most compelling evidence comes from the Arctic Ocean, where drill cores reveal tidal deposits from periods when this polar sea was ice-free and temperate. The tidal patterns preserved in these sediments suggest ocean connections that don't exist today, passages between ocean basins that allowed different tidal systems to interact and create complex interference patterns. Scientists studying these ancient tidal records have discovered something that challenges our understanding of how quickly our planet can change. The evidence suggests that major shifts in sea level and continental configuration have occurred much more rapidly than previously thought, sometimes within thousands rather than millions of years. As we map these submerged landscapes and decode their tidal signatures, we're forced to confront an unsettling question. If entire continents can vanish beneath the waves while leaving only subtle traces in tidal patterns, what other transformations might our planet be capable of? In the quiet precision of a Swiss watch, each gear turns at exactly the right speed to measure the passage of seconds, minutes, and hours. But Earth itself operates as an even more elaborate timepiece, one whose mechanisms are written in the rise and fall of tides, and whose accuracy spans not hours, but eons. This planetary clockwork operates on a principle so elegant it seems almost designed. As tides rise and fall against shorelines around the world, they create friction that gradually steals rotational energy from Earth's spin and transfers it to the Moon's orbital motion. It's as if our planet has been winding down like a cosmic music box for billions of years, playing a slower and slower melody as time passes. The precision of this system is breathtaking. Scientists studying tidal rhythmites, those layered rock formations created by ancient tidal cycles, can calculate the exact length of days millions of years in the past. A fossil coral from the Devonian period, 380 million years ago, reveals that a year then contained about 385 days, each lasting roughly 22.5 hours. The mathematics is so precise that paleontologists can determine not just how fast Earth was spinning, but exactly where the Moon was in its orbit. This tidal timekeeping system has revealed some of Earth's most closely guarded secrets. During the late Precambrian, about 900 million years ago, days lasted only 18 hours. The Moon appeared enormous in the sky, about twice its current size, and tides reached heights that would seem catastrophic today. These supertides may have played a crucial role in mixing the oceans during snowball Earth periods, preventing them from freezing solid. But the clockwork of tides reveals more than just the slowing of Earth's rotation. Hidden within tidal patterns are signatures of major geological events that altered our planet's spin. The formation of major mountain ranges, massive volcanic eruptions, and even asteroid impacts left their marks in the tidal record by slightly changing Earth's moment of inertia, its resistance to rotational change. The most remarkable discovery came from studying tidal deposits formed during the end Permian extinction, the greatest mass extinction in Earth's history. Scientists found subtle changes in tidal patterns that suggest this catastrophic event actually altered Earth's rotation rate, possibly due to massive volcanic activity that shifted material around the globe. Modern satellite measurements have confirmed that this tidal clockwork continues today with meticulous precision. Laser ranging experiments that bounce light off reflectors left on the Moon by Apollo missions show that our lunar companion is receding at exactly 3.8 centimeters per year. This means that in about 600 million years, the Moon will appear too small to completely cover the Sun. During solar eclipses, those perfect alignments that have awed humanity throughout history will become impossible. The implications stretch far beyond astronomy. As the Moon recedes and Earth's rotation continues to slow, the length of our days will keep increasing. In a few billion years, a single day will last as long as a current month, with the same side of Earth always facing the Moon, a phenomenon called tidal locking that we already observe between the Moon and Earth. This cosmic clockwork also reveals something profound about the nature of time itself. The steady lengthening of days means that the very rhythm of existence on Earth has been gradually changing since life began. The circadian rhythms that govern everything from plant photosynthesis to human sleep cycles are slowly falling out of sync with the planetary clockwork that created them. As we contemplate this vast machinery of time, we're left with a haunting question. If tides can serve as such precise chronometers of the past, what do current tidal patterns tell us about the cosmic clockwork of the future? Beyond our own world's shores, in the frozen darkness of outer space, An invisible ocean heaves and breathes beneath miles of ice. Europa, Jupiter's moon, experiences tides so powerful they crack its frozen shell like an eggshell, creating the dark lines that streak across its surface like ancient scars. These alien tides work differently than our familiar earthly cycles. Instead of being pulled by a single moon, Europa is caught in a gravitational tug-of-war between Jupiter's immense gravity and the orbital resonance of its sister moons. This creates a flexing motion that generates enough heat to maintain a liquid ocean beneath the ice, an ocean that may contain twice as much water as all of Earth's seas combined. The tidal forces on Europa are so intense they literally stretch and compress the moon's rocky core, generating the internal heat that keeps its hidden ocean from freezing. Scientists studying these alien tides have discovered something remarkable. The patterns of tidal heating create convection currents in Europa's subsurface ocean that might be similar to the deep-sea thermal vents where life first emerged on Earth. Even more intriguing is Enceladus, Saturn's small, icy moon that shoots geysers of water vapor into space from cracks near its south pole. These dramatic eruptions are driven by tidal heating as Saturn's gravity flexes the moon's interior. The water vapor from these geysers has been analyzed by spacecraft, revealing that Enceladus's hidden ocean contains the basic chemical ingredients necessary for life. These discoveries have revolutionized our understanding of where life might exist in the universe. Traditionally, scientists looked for planets in the habitable zone, the narrow orbital distance where liquid water could exist on a surface. But tidal heating expands this zone dramatically, creating the possibility of liquid oceans around planets and moons far from their parent stars. The implications are staggering. In our own solar system, at least 5 moons are thought to harbor subsurface oceans maintained by tidal heating. Europa and Ganymede around Jupiter, Enceladus and Titan around Saturn, and possibly Triton around Neptune. Each of these worlds represents a potential oasis of life in the cosmic desert. But the story becomes even more extraordinary when we consider exoplanets, worlds orbiting other stars. Astronomers have discovered thousands of these distant worlds, and many exist in complex gravitational relationships that create powerful tidal forces. Some exoplanets are tidally locked to their stars, with permanent day and night sides, while others experience extreme tidal heating that might maintain global oceans even on worlds far from their parent stars. One particularly fascinating example is Proxima Centauri b, the nearest exoplanet to Earth. This world orbits so close to its red dwarf star that it's likely tidally locked, but the temperature gradient between its eternal day and night sides might drive atmospheric currents that could redistribute heat and maintain liquid water in a perpetual twilight zone. Tidal forces also play crucial roles in planetary formation and evolution. The early solar system was a chaotic dance of gravitational interactions, with tidal forces helping to shape planetary orbits, clear debris, and even determine which worlds would retain atmospheres and which would lose them to space. As we study these cosmic tides, we're beginning to understand that the familiar rhythm of Earth's oceans is just one movement in a vast symphony of gravitational forces that spans the entire universe. Every planet, moon, and star participates in this cosmic dance, creating conditions that might nurture life in ways we're only beginning to imagine. The question that emerges from these discoveries is profound. If tidal forces can create and sustain conditions for life throughout the cosmos, might the universe be far more alive than we ever dared to dream? Tonight, as you listen to waves against the shore, you're witnessing a conversation between past and future, one written in the rising waters that carry both ancient memories and urgent warnings about what lies ahead. The tides that once served as humanity's most reliable timekeeper are now changing in ways that would have seemed impossible to our ancestors. Sea levels are rising at an accelerating pace, not just from thermal expansion as oceans warm, but from the massive ice sheets of Greenland and Antarctica adding their ancient frozen archives to the global mix. Each summer, as Arctic ice melts in unprecedented amounts, it's as if Earth is releasing memories frozen for millennia. But this isn't simply a story of melting ice. modern tidal patterns are revealing something far more complex and troubling. The shape of ocean basins themselves is changing as the weight of rising water literally deforms the seafloor and depresses coastal lands. This phenomenon, called post-glacial rebound and glacial isostatic adjustment, means that tidal patterns are shifting in ways that ancient civilizations could never have imagined. Coastal cities that have relied on predictable tidal cycles for centuries are discovering that their traditional flood defenses no longer work. Venice's Aqua Alta floods now arrive more frequently and reach higher levels, while Miami Beach experiences sunny day flooding during high tides even when no storms threaten. The Thames Barrier in London, designed to protect the city from storm surges, now closes more often for routine high tides than it was ever intended to. Scientists studying these changing patterns have made a disturbing discovery. The relationship between astronomical tides, caused by celestial mechanics, and meteorological tides, caused by weather patterns, is becoming increasingly unstable. Storm surges now ride atop higher baseline sea levels, creating compound flooding events that exceed all historical precedents. The implications reach far beyond coastal flooding. Changing tidal patterns are altering ocean circulation systems that have remained stable for thousands of years. The Gulf Stream, which carries warm water northward and helps moderate Europe's climate, shows signs of weakening as changing tidal dynamics interact with freshwater input from melting ice sheets. Even more concerning is the discovery that rising seas are triggering feedback loops that accelerate the process. As water levels rise, they increase tidal friction in shallow coastal areas, which paradoxically causes Earth's rotation to slow even faster. This creates longer days, which alters atmospheric circulation patterns, which affects weather systems, which influences ice melt rates, a cascade of changes that amplifies with each cycle. Archaeological evidence reveals that human civilizations have always adapted to changing sea levels. But the current rate of change is unprecedented in human history. Entire island nations like Tuvalu and the Maldives face complete submersion within decades, while major deltas like the Nile, Ganges, and Mississippi are experiencing rates of relative sea level rise that threaten to displace hundreds of millions of people. Yet within these challenges lies a profound opportunity for understanding. The rapid changes occurring today are creating natural experiments that allow scientists to study tidal dynamics in real time rather than reconstructing them from geological records. Satellite altimetry, GPS monitoring, and deep ocean sensors are creating an unprecedented dataset that reveals how tidal systems respond to changing boundary conditions. This modern tidal archive is already yielding insights that could help predict future changes with greater accuracy. Machine learning algorithms trained on current tidal data are beginning to identify subtle patterns that might forecast where and when the most dramatic changes will occur, potentially giving coastal communities precious time to adapt. As we stand at this intersection of past and future, the tides remind us that change is the only constant in Earth's history, but they also whisper a more hopeful message. That understanding these changes gives us the power to navigate them wisely. As our journey through time and tide draws to a close, listen once more to the ancient rhythm that has accompanied us throughout this exploration. The waves washing against distant shores carry the same cadence that lulled the first complex life forms in Precambrian tidal pools, the same pulse that guided Polynesian navigators across vast oceanic distances, the same eternal breathing that will continue long after our own chapter in Earth's story has ended. In this moment of quiet reflection, consider the profound interconnectedness we've discovered. Every tide contains multitudes, the gravitational embrace of celestial bodies, the accumulated history of geological epochs, the chemical signatures of vanished continents, and the promise of future worlds we can barely imagine. What we once perceived as simple water moving up and down a beach reveals itself as nothing less than Earth's own heartbeat, marking time on a scale that dwarfs human civilization. The tidal forces that seem so gentle and predictable are, in reality, among the most powerful shapers of our planet's destiny. They've slowed our world's rotation, stabilized our climate, concentrated the organic molecules that sparked life, preserved the fossil record that tells us where we came from, and now offer warnings about where we might be heading. Perhaps most remarkably, we've seen how tides serve as a bridge between the familiar and the cosmic. The same gravitational forces that determine when you can walk on a tidal flat during low tide also govern the hidden oceans of distant moons, potentially nurturing alien life in the darkness beyond our solar system. The mathematics that ancient civilizations used to predict local fishing conditions also describe the orbital dynamics of exoplanets circling other stars as you drift toward sleep, carried by the metaphorical tide of consciousness ebbing toward dreams. Remember that you're participating in rhythms far greater than yourself. Your own biological cycles, the circadian rhythms that govern sleep and waking, the monthly cycles that connect human life to lunar phases, even the beating of your heart, all echo the deeper rhythms that tides have been teaching life on Earth for billions of years. The ocean continues its ancient conversation with the moon, whispering secrets in a language written in salt water and gravitational force. Some of these secrets we've learned to decode: the length of ancient days, the paths of vanished continents, the orbital history of our solar system. But countless others remain hidden, waiting for future generations to develop the wisdom needed to understand them. Tonight, somewhere in the world, a child is collecting shells in a tidal pool, unconsciously following in the footsteps of every curious human who has ever wondered about the sea's mysteries. Somewhere else, scientists are analyzing core samples from the deep ocean floor, reading Earth's diary written in microscopic fossils and chemical signatures. And in space, robotic explorers are studying the tidal-heated oceans of distant moons, searching for signs of life that might share our cosmic origins. The tides rise and fall with ancient patience, carrying their cargo of secrets from the deepest past toward an unknowable future. They remind us that we are part of something larger than ourselves, a planetary system, a solar system, a universe where gravitational forces weave together matter and energy, space and time, life and death, in an endless dance of becoming. As the tide recedes from this story, it leaves behind a question that ripples outward like waves from a dropped stone. If the simple rise and fall of ocean water can reveal such profound truths about our planet's past and future, what other everyday mysteries around us are waiting to yield their secrets to patient observation and wonder? The eternal rhythms of the sea continue their ancient song, and in their music, those who listen carefully can hear the echoes of everything that has ever been, and the whispered promises of everything yet to come.